Hello and welcome to the fourth video of this DSA problem solving series on YouTube. Today we are going to see another question from the same topic as the previous video, linked list. This is a very important question because questions based on this theme and this exact question has come in interviews of companies such as Microsoft, Google, Qualcomm, Amazon. So let's get started. Okay, so this is the question, partition list. Let's give it a read. Given the head of a linked list and a value x, partition it such that all nodes less than x come before nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions. It's a fairly simple question, but let us just read it one more time. Let's try to understand what it's saying. So what it's saying is it is going to give two inputs. One is the head node of the linked list and another is an integer x, and all the numbers which are less than or equal to x should come before x, and all the numbers which are greater than x should come later. But the relative order of the node of the given node shouldn't get affected by these conversions. So let us go to the board to see what the question is saying. Okay, so I do not know the exact input, so I will be taking the arbitrary input. If I remember correctly, it was something like this only. So let's see. So let's say if this is the head node, and it's the head node given to us, and x is, let's say, 3. Not screen. So this is the head node. X is equals to 3. Then what it means is the output should be 1, 2 less than 3, 4 greater than 3, we skip it, 3 equals to 3, we skip it, 2 less than 3, 5 greater than 3, we skip it. Now the question comes, 2's next, should it be 3 or 4? It should be 4. We should maintain the relative order of the nodes as was given in the question. We are not sorting this linked list, we are just doing these changes. We are partitioning it by the value of the x. So I hope that should be clear. This will be the output. 3 won't come before 4. We are not sorting the names. So if you understand this question correctly, I don't think the approach is very far-fetched. You can get it. So yes, I think I should use. Yeah, much better. So let's see what the approach should be like. 1 less than 3, 2 less than 3, 4 greater than 3, hence we put it in another list. 3 equals to 3, next of another list. 2 less than 3, 5 greater than 3, hence we put it here. And when there is no element left, what we do? We point the last of the first list to the second list. It's as easy as that. What will this become? It will be 1, 2, 2, 4, 3, 5, which is the output which we were initially looking for, right? So this is the approach which I could come up with. Let me know if there is a different approach. Two linked lists. In one linked list, we put all the elements less than 3, less than x, and in the other one we put all of them greater than x, and then we join the two linked lists. So this is all about the approach, and we'll just quickly hop onto our coding window again. Okay. So I did not explain all the variables and everything on the board this time because I thought that we might do that at the coding window. So you'll have to bear with me. The approach, if you know code is just particulars, this code will be a bit longer because, uh, well, the approach, that is the requirement of the approach, let's say. So we'll have to have head nodes of both uh, both the linked lists. This code does require a lot of memory, so we need two head nodes and rear nodes. So instead of rear, I'll just write last. The head nodes are the head nodes of the two linked lists, and the last is the current node, let's say, of the linked list. You can write current as well. And then another one we need to traverse through this, and this will be equals to head, the head of the given linked list. Border condition which we have to take care of is if head equals null, then we simply return head. That is, if the linked list which is given is empty, well, we return it as it is. Otherwise, we traverse through it. How do we traverse through it? Like this. While p, we can also write while p is not equals to null, one and the same thing. Now, we need two more variables. These variables, in my terminology, I have coined this term. I call them the flag variables. So we'll see their use in just a moment. Bear with me till then. Okay, let's see. If I'll write the code first and then I'll explain why these are called flag variables and why we require them. If head equals 0, we do something, else we do something. And this whole thing obviously comes if the condition is that if this variable is less than the variable or greater than the variable. So if p's value is less than 3, that's when we use this. Just bear with me for just a moment and I'll explain the structure of our code. After that, we can obviously keep doing what we like. Okay, I've created the structure of our code and let's understand it one by one. This will be 3 not x not 3. So what I've done is we are traversing through the given array because p is equals to head, and in the end obviously we do p equals p next. So what we are doing is we are traversing through this linked list, and what is the condition whether p, the value of the current item, whether it will be less than x or equal to x. So this if box and this else box represents that. Now let us go inside this if box. There is another if else condition. Why is that so? And what are these flags? Well, let us go on further. And the same is done in else. So you can understand in both the linked list that we are creating. We have done this. So let's see what these flag variables are. So here we'll do L1 head equals these value and L1 head's value, and then we'll do L1 last equals L1 head because this is the current variable, and then we'll do head 1 equals 1. So this condition is given only 1, and else if the flag variable is equal to 1, which you set here, what is to be done there? Well, you might not find it very difficult to believe. We initiate another temp variable. You can call it anything. I like to call it temp. You can call it current, you can call it anything else as well. So this temp variable and this temp variable's value will be equals to p's value and L1 last next will become equals temp, and then finally L1 last, which is the current node, is temp. These patterns you have seen if we have solved linked list questions. So again, what is this code? Let me explain. Why this head one? Why this flag? Okay, let's see. There are two different methods. We have to know the head of our first linked list and the head of our second linked list. The simple reason being the head of the first linked list will be used to return our answer, because that's where our linked list will start from. And why do we need the head of the second linked list? Because the last pointer of the first linked list will connect to the head of the second linked list. I hope that's clear. And this is why this flag is used to tell us whether the head of this linked list has been filled or no. So if head is not filled, L1 head, if it was equal to null, we would initiate it like this. Otherwise, if it's any other node but the head, we will do it like this. I hope that's clear. We have something very similar on the other hand as well. So I'll just copy paste it and then we'll change the variable names. This is why it's important to use variable names which are very general, so they can be changed like this with ease. Right. Temp doesn't need to be changed because well, it's temporary, so it can be same for both the things. Okay, now this is done. Now what to do? Well, we have to take care of another border condition. By the way, I just used it out of the loop, I believe. Out of the while loop, I used it. So this will be the border. Now we have to take care of another border condition, which are these. If head 1, we need to return L2 head. If head 2 equal 0, we need to return L1 head. Why did I do this? That is in case if the x variable is such that either all the variables in the linked list are less than the variable, or all the variables in the linked list are greater than or equal to that variable. So in that case, one of the linked lists will be empty and the other one will be full. And so in that case, we wouldn't be required necessarily to return L1 head. So we have to return L1 head. Are we forgetting something? Yes, we are. But we need to join the two linked lists. So L1 heads, L1 last, I'm sorry. Next becomes L2 head. Um, it's a very big code, so there are chances of errors. So let us try run it in this test case. It is accepted. Let us submit it. It is accepted. As you can see, it is nowhere near the most optimal solution. This is the solution which I could come up with. I would love to know and hear what other people's solution are. Let us have a discussion over this. I hope you enjoyed this video. Thank you very much.